Hi everyone. In this video I am going to explain about parity circuits. Parity circuits are nothing but which are used to produce parity bits. Parity bits. So a parity bit is used for the purpose of detecting errors during transmission of binary information. So I am writing here a parity bit is used for the purpose of detecting errors during transmission of binary information. So a parity bit is an extra bit. Generally parity bit is nothing but it is an extra bit during transmission. Suppose if you have 8-bit data to transmit, along with this 8-bit data we are adding one parity bit along with that. Okay, then the data will be a size of 9. Okay, so that extra bit is nothing but a parity bit. So a parity bit is an extra bit included with a binary message to make the number of ones either odd or even. Suppose I have the data 0, 1, 1. For example, I have a message which is of 3-bit 0, 1, 1. So 0, 1, 1, if you want to use odd parity, you are using an odd parity technique, then for this odd parity the bit should be 0, because after adding this bit in the odd parity the entire message consisting of odd number of ones. In that case here we should use 1. For odd parity this number should be 1. Then how many number of inputs, how many number of ones are there? 3. So 3 is an odd number. Suppose if it is an even number, even parity, then it is 0. So 0, 1, 1, 0. Then it is the total message bit of 4-bit. Out of these 4 bits, 1 bit is from parity bit. And to make, after adding this parity bit, the entire message should consist of even number of ones. That is the meaning of odd parity and even parity. Okay, so there are two types of parity related circuits we need. One is parity generator, another one is parity checker. Parity generator and parity checker. Where we are using this parity checker and where we are using this parity generator? Parity generator is used at the transmitter place and parity checker is used at the receiving place. So the message including the parity bit is transmitted and then checked at the receiver for errors. An error is detected an error is detected if the checked parity, if the checked parity does not correspond with the one transmitted, with the one transmitted. The circuit that generates the parity bit in the transmitter side is called parity generator, and the circuit which checks the parity whether it is correct or not, that is parity checker, and which is available at the receiving side. Okay, that is the meaning of this one. Okay, so the added parity will make the total number of ones is either odd or even, depending on the parity bit that is either being added, that may be either even or odd. Okay, let us see, consider 3-bit message, consider 3-bit message, and what is the odd parity? Let's see the odd parity and even parity bits, odd parity and even parity bits. Okay, so now see here, 3-bit message, 3-bit message, odd parity and even parity. That means what should be the bit in the odd parity and even parity, and its corresponding odd and even parities. So we know for 3-bit message means 000 to 111. So 000, 001, 010, 011, 100, 101, 110, 111. And odd parity means here there are 3 zeros. If you take 1, then 0001 means the total message bit is 0001. How many ones are there? 1. So odd number of ones are there. But if you want to make that even after adding the parity bit, if you want to make it as even parity, then 0. And similarly it is 0, it is 1. And here also it is 0, it is 1, because you no need to add 1 here, because it is having 0, 1, 0, and this 0 will be appended either of those positions. So then overall ones is only 1. And similarly it is here 1, 0, it is here 0, 1, it is here 1, it should be 1, 1, 0. And similarly here also it is 1, it is 0, and 0, 1. Okay, so this is what the odd parity and even parity outputs. So based on this we can simply write the expression, a Boolean expression as odd parity. So odd parity, what is the Boolean expression? When it is 1, when 3 zeros are there, 0, 1, 1 is there, and 1, 0, 1, 1, 1, 0. And similarly even parity will occur in the remaining cases. Okay, odd parity, even parity, both are exactly opposite to each other, complemented. Both are complemented to each other. It is a complemented version of both, one is to another. So odd parity bar is equal to even parity, or even parity bar is equal to odd parity. Now so P even is equal to A bar, B bar, C bar. P even is equal to A bar, B bar, C bar, plus, and it is again A bar, B, C, plus A B bar C plus A B C bar. Okay, based on the ones, wherever we are having ones, the corresponding binary information is written, and P odd is equal to P odd. Okay, let us write the simplest form of this one. So you can write it as A XOR B XOR C, and similarly P odd is A bar B bar C plus A bar B C bar plus A B bar C bar plus ABC. So if you simplify this again, you will get A XNOR B XNOR C. A XNOR B XNOR C, you can write it as A XOR B XOR C whole bar. See, so there is a complementary relation between even and odd parity bits. Okay, and we can simply draw the circuit also for these two. So parity circuits, even parity is nothing but just an XOR operation. See here XOR operation. So take a 2 input XOR, 2 input XOR AB, and again the output is passing through one more XOR gate, this is C, and then it is A XOR B XOR C. Okay, this is what? Parity, even parity, and if you go to odd parity, simply complement of this one, will give you odd parity. So P odd parity is equal to A XOR B XOR C whole bar. Okay, A XOR B XOR C whole bar, nothing but A XOR B XOR C. Okay, so this is just simple parity generator and as well as parity checker outputs. It is just a parity. What could be the parity output for the corresponding input? Okay, in the next video I will tell uh, how to write the VHDL code for this one. Okay, and also we can also verify parity error checking in the next video. Okay, thank you.